It's okay. So, okay, I will just continue from where I left off. So, the SAT section has a calculator section and a no calculator section, and now I'm going over the basics of each section. Okay, so the no calculator portion, there are 20 questions, and 15 of them are multiple choice, and 5 of them are student-produced response, which are grid-ins, and these are questions where they don't give you answer choices for you to pick from. You have to figure out the answer choice yourself, but you have to bubble in your answer. So that means for each digit that you have, you put in your answer. You bubble that digit in. And then it covers 3 content categories: Heart of Algebra, Passport to Advanced Math, and additional topics in math. So the first 2 we're going to be covering today. And then for the calculator portion, it's longer, so it's going to cover all 4 categories. There will be 30 multiple choice questions and 8 student-produced response answers, or grid-ins. And these are going to be longer, and since there are more of each type, it's going to be harder too. Okay, so these are the sections more in detail. Heart of Algebra, there are 11 questions. Problem solving and data analysis, there's 17 questions. So this one is more of the focus in the calculator portion. In Passport to Advanced Math, there's 7, and in additional topics in math, there's 3. Okay, so let's look at Heart of Algebra. So Heart of Algebra, these topics it will be covering will be solving linear equations and linear inequalities, interpreting linear functions and graphing linear equations, and solving systems of linear equations. You probably already saw this on the Google form that I sent out before, but this is basically what we're going to be covering today. And then mostly for the questions, you usually solve for the variable in functions or systems of inequalities. Determine whether a given point is in like a solution set that they give you, or like what value would make the expression have no solution, or maybe all of the solutions. You can select a graph, so a lot of this is like looking at graphs and seeing if the graph matches your equation, or seeing the equation and being able to graph it. So you have to be able to choose that, and then you have to see how a graph is affected by its equation. So we're going to go over all of that today. The second part is Passport to Advanced Math. There are many more sections here. So we're going to go over solving quadratic equations, interpreting nonlinear expressions or nonlinear equation graphs, radicals and rational exponents, and like division, multiplication, addition, and subtraction with radicals and polynomials. And then operations, that's basically operations with rational expressions and polynomials. Polynomial factors in graphs, linear and quadratic systems, isolating quantities and like equations. And then mainly there's functions. So, okay, I see in the chat. Yes, okay, we will have access to the slides. I will post it in the Google Drive. Okay. And then, so with these topics, usually you solve these polynomials by factoring or rewriting them in like a different form. Like for quadratics, you might write it in a different form. We're going to go over all of that later. And then this is what I was talking about: adding, subtracting, multiplying, or dividing two rational or polynomial expressions. And then selecting a graph again, because you have to match the graph to the equation. This is what we're going to be doing still. And then we have to figure out how the graph would change if the equation is changed again. So there's a lot of overlap between these two. A lot of it is algebra. And we're just going to be going up the basics. Okay, so now we're kind of moving on to like the strategies. Here are just some unique features of the SAT that are helpful. So, number one, there is no guessing penalty. So that is very helpful. I know on some tests that you've taken, there are guessing penalties. So if you cannot finish in time and like you don't know the answer to any of it because you've never read it, then you can just guess. I usually just guess the same answer every time because it's kind of a fixed probability. On the SAT, there are 4 answer choices. So you basically have a 25% chance of getting it right. If you can limit it to like less than 4 choices, it's even better. If you don't know the answer, just guess. And then there are these extended thinking problems. So these problems involve several questions and they're like linked. And they're typically part of the grid-in questions just because it's kind of supposed to be harder. And these extended thinking problems, a lot of it is like application to real life because the SAT really tries to feature that in their problems. And then, of course, there are the grid-in questions. So I'm going to go more in detail about these grid-in questions. This is like the normal SAT answer sheet. And these questions at the bottom are the grid-in questions. So the grid-in questions, they usually provide you with 4 boxes, and you have this kind of multiple choice bubbling and answer thing at the bottom. So you can write it in terms of fractions. So over here, there's 7 divided by 12. And so you bubble in each digit and like the fraction symbol. And then you can also write it as decimals. You can round it. So you can also do like acceptable ways for 2 over 3 would be 2 over 3, 0.666 or 0.667. So the rounding, it doesn't really matter in this case. And then the positions don't matter. So you can, if there are only like 2 or 3 digits, then you can just move it in the answer choice and they won't like mark it wrong. Okay, and now scoring. So for the SAT, you have your raw score. So your raw score is exactly how many questions you got correct in your math section. Then they convert it into your math section score. So this is like a typical math section conversion from raw score to the math section score. This is from one of the years, so you can kind of check your like what your score would be if you take a practice test. So typically you kind of need like less than 3 wrong to get like an 800, and then after that it becomes like lower really quick. So try to kind of limit yourself to or practice testing and seeing like what your score is. Okay, so now we're officially moving on to my strategies. So these are going to come in forms of like small tips. Okay, so tip number 1, take lots of practice tests because that would really help. It will help you determine like which areas you struggle in most and how much time you take for each section. and like what you need to do in order to like get faster or get more accurate. And so you can kind of gauge where you are on like your SAT score right now. Okay, number 2, time yourself, because time is very important. It's kind of fast for the SAT, so my estimate for the no calculator section, because it's longer, usually like 45 seconds per question. Well, no, the no calculator section is shorter, so it's 45 seconds per question, and the calculator section is longer, so it's like 1 minute per question. I'm talking about the multiple choice answers. The grid-ins, they will definitely take longer, so they will give you a longer amount of time. But basically they're testing how fast you can react to a type of problem and making sure you can understand like what you need to do in order to solve it. Okay, so tip number 3, don't be afraid to guess again. So you try to narrow the answers down, and since there are only 4 answers, if you already narrow down 2 of them, you have a 50% chance of getting it right, and that's pretty high. Okay, so tip number 4, be familiar with the subjects they are testing you on, because some students like go in not really knowing what's on the test, and they just think like they can breeze through it, but it might be unexpected, because I think the problem solving and data analysis part, maybe that might be kind of unexpected and not a lot of students prepare for it, because it's not really taught that much in school.
I'll try.
Okay, can you please mute while I'm talking, if you are unmuted, because that would be helpful. Okay, so tip number 5, so be familiar with the graphs. So the graphs they're going to test you on, like linear graphs, exponential graphs, logarithmic graphs, and probably quadratic equations or polynomial expressions. And know how they are constructed too. So make sure that you know how to graph one of these from an equation, and if you have the graph, make sure you know how you can find the equation. Okay, so tip number 6, like review the formulas you need in order to take the test. So a lot of the tests, they kind of try to trick you. So a lot of times you have to pay attention to the conversion and the units they are asking for. One example, examples of formulas you need to know: area of a triangle, that's like definitely the most important one. Like the volume of a cone, volume of a sphere, volume of a pyramid, and unit conversion. And there are also many more. I don't think that the formulas are given. Okay, so you kind of need to go, unless they give it to you in the problem. But some of the main conversion problems, maybe like yards, you have to know is 3 feet, or like a meter is 100 centimeters, that type of thing. Okay, so tip number 7, so read closely. So again, this is about the units and conversion, and make sure you calculated the units correctly. One easy way to check if you kind of did it correctly is like to make sure that it makes sense in the problem. So look back at the question that you're trying to answer, and make sure that it fits what you got makes sense in the problem. And usually I like to read the question again to make sure I have that. And then if you have time, try to double check your answer, because that's always helpful. Okay, tip number 8. So for word problems, basically it's about boiling it down to the basic points. So make sure you know what you're trying to solve and like how you can reduce these like sentences into a few equations. So for every like variable you're given, or for every new thing you're introduced to that you kind of need to use in the problem, try to make like a variable if you need it and make equations with it. Okay, so now we're kind of moving on to the main lecture. So keep in mind, like try to answer these examples as I'm giving it, and I'll give you like 2 minutes for each one. If you have the answer, you can send it to me in the chat and I will go over it afterwards. Okay, so number 1, we're going over heart of algebra, and we're on solving linear equations and linear inequalities. Okay, so we have to first know like what exactly are linear equations or linear functions and the forms that they come in. So linear equations and linear functions, I'm pretty sure you know they are a straight line. Okay, but they usually come in these 4 forms. Number 1 is slope-intercept form. So this is y equals mx plus b, where m is the slope and b is the y-intercept. So if you have a line like this one, m is the slope, which means that it is the rise over the run. The slope between any 2 points on the line is constant. So for every single 2 points that you pick that are on this line, the slope between them will be constant. And the slope is calculated by the y values, like y2 minus y1 over x2 minus x1. So if you have like a y2 first, then on the denominator, in the denominator, you have to have the x2 first, the coordinating x component. Okay. This is one that you use very frequently. So if you have y equals mx plus b anywhere, then you know that you have the slope, which is the m, and then the b is the y-intercept. That means it goes through the y-axis at that point 0, b. Okay. The next one is the point slope form. So this one I like to use when you are given 2 points and you're trying to find the line. So if you have y minus y1 equals m times x minus x1, you have m is the slope again. And then y is like your variable. y1 is one of the points on the line. So x1, y1 is the known point on the line, and in order to find the slope, you need another point on the line. So that's how you can calculate it easily. And then these two, you can easily convert from one to the other because you add y1 on both sides, from the point slope form to convert to the slope intercept form. But these are generally not given on the test. In the test, you will often see the general form and the standard form. So the general form, all the variables are moved onto one side, and this equals 0. Okay, and in the standard form, you have ax plus by equals c. C is a constant, it's a number. Okay, so when you are given these on the test, always try to convert to the first 2 forms because those are easier to work with. Okay, and then just remember that the slope is constant. This is a very important fact. Okay, so let's go on to one of the examples. I will give you 2 minutes, and if you have the answer, type it to me in the chat. Okay, perfect. All of the answers that I saw were correct. Okay, the answer was A. So, if you did not have this answer, just use the slope is constant. So I will model it for you. Okay. We will start with, we know this table. So we know that 0, comma A lies on this line, 1, comma 12 lies on this line, and 2, comma B lies on this line. So the slope is constant. So we know that y2 minus y1 over x2 minus x1 is the slope. And this is always constant. So we can use this by taking the first two ones, so 12 minus a over 1 minus 0, and then this is equal to the slope. And then we can also take the second two because we know 1 and 12, so that's the easiest to take. So we have b minus 12 over 2 minus 1. So 1 minus 0 is just 1, 2 minus 1 is just 1. So we only have 12 minus a equals b minus 12. So then if we move the two variables onto one side, we have that a plus b, oh my gosh, equals 24. And that is a. Another way that you could see this is if you draw a graph. So if we have a line, we know that this slope is constant. Let's just say that it goes through 1, 12. This is not a very accurate graph. But if we have a point over here at 0, and if we have a point over here at 2, where this is the x-coordinate, this is the y-coordinate, we have that the average of these two for the y-coordinate, okay, is going to be 12. So if we have that, we have a plus b over 2 is 12, and then we have a plus b is 24. So that's just a way to visualize. Okay, next problem, we have example number 2. You can try to solve this. I'll give you 2 minutes. Okay, I did not see anybody send me the answer in the chat, but I will go over it. So this one I know is harder, but the answer is A. So we need to use the fact that the slope is the rise over the run. So this is the change in y over the change in x. In this equation, the y would be the f and the x would be the c. So Fahrenheit would be the y and the c would be, well, the Celsius would be the x. So I will model this for us. So we know that the change in the y, because we have y2 minus y1 over x2 minus x1, is the slope. And in this equation, the slope is 9/5. Okay? And then we have the change in the y. So the change in the y, this is just the change in the Fahrenheit. So it increased by 27. So this is positive 27. Then we need to find the change in the C, the Celsius. So we have that the change in the Celsius, we're going to do delta C, this is change in the Celsius, is equal to 27 times 5/9. Okay? I hope you can see this because we multiply by delta C on both sides and then we multiply by 5/9. And this will move all of the numbers to one side. And this would be 15. So the answer would be A. Okay. Let's move on to the next problem. So again, you can try it by yourself for 2 minutes and then I will go over the answers. If you have the answer, you can give it to me in the chat. Okay. Yes, all of you guys who gave it to me in the chat, you got it right. So the answer is C. So an easy way to do this is to use point slope form. So point slope form is the one that I told you about. Y minus, I will write it. We have y minus y1 equals m times x2 minus x1. Okay, so this is an easy way to solve this problem. You have the slope, -1/2, and then you have one, it should be x minus x1. Okay, yes, that is point slope form. Okay, so we have the slope, which is -1/2, and then we have one of the coordinates. So we have x minus 2 is equal to y minus 2 because both of the coordinates here are 2. And then we need to find the x-intercept of the line. So the x-intercept is the point where it intersects the x-axis. So that is when y is 0. So we plug in y is 0. So 0 minus 2 is equal to negative 1/2 times x minus 2. So then we have, I will skip some steps, okay, because I am running out of room. And this is basically, we multiply by negative 2 on both sides, and then x equals 6. Okay, so since it's on the x-axis, the y component is 0, the y coordinate. So we have the answer, which is C. Okay, let's go on to the next problem. Okay, so now we are moving on to interpreting linear functions and graphing linear equations. So this is mostly about graphing. Okay, and so we have linear equations. For linear equations, well, more than 2 or more than 1 linear equation, there's going to be 3 different cases. Okay, so the first one is when the system has exactly one solution. So this is when the two slopes are different. They intersect at one point and exactly one point. Now, if we see a problem that's asking for when there is no solution, then we have that the two lines are parallel, but they have a different y-intercept. So that means that these two lines will never touch, and they are not the same line. Okay? And then we have that the system has infinitely many solutions. This means that the lines are identical and they have the same y-intercept. So think about when you see the problem, if it asks for one solution, then you know you have this first one. The two lines have different slopes. If they ask for when these two lines do not have any solution, then you know that this is when the two slopes are the same. They are parallel. Okay? And then if the system has infinitely many solutions, you know that that line or the two lines basically describe the same line. So that is when you solve for it. This seems pretty intuitive, but it's very helpful. Another important part is if you know two lines are perpendicular, the product of their slope is -1. So you know that if one line has a slope of m1, then the second line has a slope of -1 over m1. Okay? Okay. And then we also know for graphing, know the 4 quadrants. So we have, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And if you can, try to graph these linear equations because especially if we're solving like inequalities, it can be helpful. And then when you already have an equation, you can just plug in the points. If they give you the equation, plug in the points and just graph it. So if you plug in, like, you usually want to plug in like x equals 0 or y equals 0 if it is in standard form. And you can also just plug in like x equals 1, but try to make both of the coordinates integers because that just makes it easier to graph. So here's an exercise, like try to graph y equals 2x minus 4. Just grab a piece of paper and I'll give you like 1 minute because this should be pretty easy. Okay, so this was not in standard form, but it's still easy if you just plug in like x equals 0. So that point we already know is at 0, negative 4. Also, if you just test it out and see like x equals 2, that also works. So 2, 0 is also on it. It should have gone through those 2 points and it should have been a straight line. Okay, so now we can go on to the third one, solving the systems of linear equations. Okay, so for these, there are 2 common ways to solve. There's substitution, which I really don't like, so I always like to use the second one, which is just adding and subtracting these equations. So here's an example. If I have a plus b equals 20 and 3a plus b is 28, I just subtract it because I see that the b values are the same. So if I subtract it, I can get that 2a equals 8 and then a equals 4. And that's just much easier. For this one, it can also work. Like if a plus b equals 20 and 3a plus 2b is 28, I first convert the first one to 2a plus 2b equals 40. I multiply everything by 2 so that I can cancel out the 2b's. And then I just subtract. And I get that a equals negative 12 and b equals 32. Okay, for the last one, these are very ugly numbers, and these are very big. So I didn't really want to do I didn't want to do 7 times 28 because that would have been like very annoying. So I just used substitution and did it with fractions. And so that is why I use substitution for this case. Okay, so here is one example for systems of linear equations, and this is also a word problem. I will give you 2 minutes, and you can tell me your answer in the chat. Okay, perfect. So the answer was C. And we can just write out the system, so we can just use variables. And I will also model this out. So let's just first underline the most important parts of this word problem. So we have that this cost of this telephone call is determined by a basic fixed charge. So this is kind of important for the first 5 minutes. So this is always going to be there. This is fixed. Okay, and there is a fixed charge for each additional minute. So that's also important. So we have 15 minutes, and this costs $3.50. And we also have 20 minutes, and this costs $4.75. And we need the total cost of a 40-minute call. So I underlined the most important parts, and we just need to boil this down into some equations. Okay, so we have that this is a basic fixed charge. So we can say that this is one variable. Since we don't know what charge this is, we can just call it x. This is for the first 5 minutes. Okay, and then we have a fixed charge for each additional minute. So we're going to say that that fixed charge for each additional minute would be y. And so this 15-minute call, where the first 5 minutes is going to be x, and then the rest are going to be, for every minute, there's going to be y. We have that there's going to be a 10x plus 10 times y, because it's going to have the charge of y for each of the 10 minutes afterwards. Okay, and we have that this is $3.50. Okay, for the next one, we have that the same fixed charge plus 15y, because we have to always subtract that first 5 minutes. Okay, this is $4.75. Okay, and so I use my subtraction method. I just subtract. So 5y equals 1.25. So y equals 0.25. So we have that. Okay, and what are we trying to find? Well, we're trying to find the total cost of a 40-minute call. So in the 40 minutes, we have x, right? And that's always fixed. And then we have to call for 35 more minutes. So this is what we're trying to find. Okay, so I don't really want to calculate x. That's kind of long. So I will just use x plus 15y. X plus 15y plus 20y is what we want to find. So that is convenient. So we have that this is $4.75. And then this is just 0.25 times 20. So this is just $5. So this gets our answer of $9.75. Sorry, I am writing kind of big, but you should know how I got my answer now. Okay, so that's how you kind of boil down this problem into like these equations. And as you get more practice, you can do it much faster. Okay, so now we can try example number 2. I'll give you 2 minutes again, and if you have the answer, send it to me in the chat. Okay, 2 minutes has passed. So I realized this one might have been a little harder, but the answer was C. Okay, so the trick to this one is to use the slope. So remember when I talked about the three types of forms of the equations before, the systems of equations, there can be one intersection. That's when the slopes are different. When there is no intersection, so no solution, right here. Okay, that is when the slopes are the same and they are different lines. And then the last one is if there are infinite solutions, and that is one line. So for this one, since it's no solution, we have to see that the slopes are equal, but the lines are different. Okay, so I will also model this out. So because these equations are in standard form, I don't like working with standard form, so we're going to convert it into the slope-intercept form, which is the y equals mx plus b. Okay, so that is what we are trying to convert it to. So we can subtract ax from both sides, and we get that 3y equals 6 minus ax. Then we can divide by 3 on both sides. So y equals 2 minus a over 3x. Okay, so we see that the slope of this one is negative a over 3. Okay, for the next one, we have that a minus 1 times y equals 2 minus a minus 1x. Okay, so that is just from subtracting a minus 1 times x from both sides. And now we can divide by a minus 1. So we have y equals 2 over a minus 1 minus 1 times x. Because this a minus 1 divided by a minus 1 is equal to 1. Okay, unless a is 1. But that's only because we are dividing. Okay, so then since these slopes should be equal, this negative a over 3 and this slope, which is negative 1, we have negative 1 equals negative a over 3. So a over 3 is 1, and a equals 3. So this is only when a is not 1, because we cannot divide by the part when a equals 1. But if we see if a equals 1, we have that negative y equals 2. And then if we have negative y equals 2, we have that y equals negative 2, and then we can find a solution to here. If we have x minus 6 equals 6, and so we have x equals 12, and that is a solution. So we just need that the slopes are equal. Okay. So now for the next example, I'll give you 2 minutes again, and you can try it. Oopsie. Okay, I accidentally forgot to animate this, but you can try to get the answer, which is 120. If you can write out the equations, that would be good, and you can send it to me in the chat once you've finished. Yes, we got it. Okay, so I will still model it out and I can help calculate it, and we can use my subtraction method because I like using my subtraction method rather than substitution. Okay, so we boil it down again. So the tickets cost $8 for adults and $5 for children. That's the main point. Okay, and then we know that there was a total of 200 tickets sold and the total amount was 1,360. So we need to find out the number of adult tickets sold. Okay, so we see that we're using adult tickets and child tickets a lot. So we can have variables. We can say that A equals the adult tickets, and we can have C equals the number of children's tickets. So the total amount sold, well, the total number of tickets sold would just be the number of adult tickets sold plus the number of child tickets sold, right? So we have A plus C has to equal 200 because we know that that is the total number of tickets sold. Okay, and then we also know that the total amount was 1,360 and that each adult ticket would be $8. So we have 8 times A plus, and each child ticket is $5. So we have 5 times the number of child tickets sold, which is 5. So we have 8A plus 5C equals 1,360. Okay, so these are some neat equations, right? And we can just do it very neatly if we just multiply the first equation by 5. So we can just cancel out 5C. So we have 5A plus 5C equals 200 times 5, which is 1,000. Okay, and then we have, again, 8A plus 5C equals 1,360. So we just subtract, and we have that 3A equals 360. So A equals 120. So this would have been one of the grid-in ones because this was not multiple choice. And so if you got 120 without like looking at the answer, that would have been good. Okay, so now we're going to move on to solving systems of inequalities because this was a subject that many marked in the Google form as needing help with. Okay, so the main advice for this part is to graph it. Okay, so once you graph it, you can just test the points that you know that fit the equation or fit the inequalities to make sure that what you graphed was correct. Okay, and so basically you first graph out the lines that it's talking about. You change the inequality to an equal sign first. So you graph those lines, and then you also just shade in the area afterwards. So if you multiply by a negative for these inequalities, make sure you switch the sign of the inequality. So if we have that y plus x is less than or equal to 6, if we multiply by -1 on both sides, we would get negative y minus x is greater than or equal to 6. Negative 6. Yeah. So you have to do that. Okay, so to graph, we need to isolate this y on one side of the inequality because it's best if you do it like that. Then you can just see if it is lower, if y is less than or equal to 6 minus x we have over here, right? So now if we have y is less than or equal to 6 minus x, we first graph y equals 6 minus x, or negative x plus 6. So after we graph it, we see that y is less than or equal to it. So the y value has to be less than it or equal to it. And then same for the other side, and then we can just shade in the area that they have in common. Okay, so now we also need like one thing to know is that the solid lines represent like inclusion. So it's less than or equal to or greater than or equal to because the points can lie on the line. If they are dotted, this means that it excludes it. So it's less than or greater than. It strictly does not include the points on the line. Okay, if you have like an inequality like y is greater than x plus 3, we just do the same thing. So we first graph y equals x plus 3, okay, and then we see that it is greater than. So this means that this is above the graph. Y is greater than. So even if the line is like really slanted, just know that it is on the top side. And then test points that you know work to make sure. So an example is that 0, 4 is a solution to it. So like over here, we have first graph y equals x plus 3, okay? So it needs to go through negative 3, 0, and 0, 3. We see that it works. Okay, so now we test a solution, right? 0, 4 is a solution. So we know that it has to be on that side of the graph. So if we shade it in, it's going to be right there, okay? And then this is also above the y, okay? So that is how you do it. You can try an example by yourself. I'll give you 2 minutes. Okay, so the 2 minutes have passed, and the answer was C. So, the trick to this one is to first find the equations of the lines in terms of y, and I'm going to use the point slope form again because I like using it. So let's first find the dotted line. So we know that it passes through 0, 0. This is like the easiest point to have. So we know from the point slope form we have y minus y1 equals m times x minus x1. Okay, so now we just plug in y1 equals 0 and x1 equals 0. So we have y equals m times x because that is the easiest point to have. Okay, and then we just need to pick another point. So we can just pick -1, 2. Okay, so we have 2 equals m times -1. So we have m equals -2. Okay, so then we have our equation. Y equals -2x. Okay, and we know that this shaded region is below that. So we have y is strictly less than -2x because this line is also dotted. So it's strictly less than -2x. Okay, and now we can just move this onto one side. So y plus 2x is less than 0. And we have two solutions. Well, two answer choices that fit that one. Okay, so now we can look and try to narrow it down using the other graph. Okay, so we have that this one passes through 0, -3, and this one passes through 3, 0. Okay, so we use the point slope form again. So we have y minus, let's take 0, -3 first. So because we always have to have the y first. So y minus -3 equals m times x minus 0. So we have y plus 3 equals mx. So now we plug in 3, 0 here. And so we have that 0 plus 3 equals m times 3. Okay, so m equals 1 in this case. Okay, so since we have m equals 1, we have our equation. So y plus 3 is equal to x. So y equals x minus 3. We isolate the y on one side. And then since this shaded region is greater than that, okay, so we have y is greater than or equal to x minus 3 because this is a solid line. So we move it all onto one side, the variables. So we have y minus x is greater than or equal to -3, and we multiply by -1 on both sides. So we have x minus 5 is less than or equal to 3. Remember to change the inequality sign. So that would be C. Okay. So next one. You can try it by yourself. Okay, so the 2 minutes are up, and the answer was B. So the trick to this one, again, is just graphing. Okay, so let's just graph it out. I have some coordinates. Okay, so we first have that x plus 2y is less than or equal to 4. So we just need to find some points here, right? So if we have like x equals, well, remember to change this to an equal signs first because we have to first graph out the line. So we have x plus 2y equals 4. So we can just find, like, plug in x equals 0, then y equals 2. So we have 0, 2 right there. Okay, and then we have if y equals 0, x equals 4. So it's right there. And then we just need to draw a straight line through that. I'm not bothering to continue afterwards because it's kind of hard on Zoom. Okay, and we know that this is less than or equal to, and y is positive on this side. So we just know that y, the positive y, is less than or equal to this line. So we just need to shade in the area below it. Okay, like that. And I will have a different color. Now we have 2x minus 1 is less than or equal to y. So we have that 2x minus y is equal to 0. That is our next line. If we have x equals 0, then y equals 0. That is an easy point. Okay, and then if we have like x equals 1, y equals 2. So we have 1, 2, which is over there. And we can draw a line through that. Okay, and we know that y is like negative here, so we can just move y to the other side. So we have y is greater than or equal to 2x. So it should be above that line. So we're going to shade in up here. So the section, it might be kind of hard to see, but the section that is overlapping is the section wait. Okay. Yeah. So, yeah. It's the section here. Okay. My graph is kind of bad. Okay, so then we know the maximum value of A, since A is the x-coordinate. Okay, so the x-coordinate, it's this one. It's 4/5. Okay? So that is the maximum value. You could also just solve these two equations and the intersection point would always be like that maximum or minimum point that it's asking for. Okay, so now we can have our linear inequality and equation word problems. So you can try this one by yourself. I'll give you 2 minutes. Okay, so we have finished our 2 minutes. Okay, this is basically a gridden problem. Okay, so we don't have any multiple choice answers. We just have to figure out ourselves. Okay, the answer was 4 because the boat rental is available only for a whole number of hours. So you can't have 4.5 or that would be wrong. Okay, so we can go over this again. So we have that the boat rental costs $60 per hour. Okay, that is important. Okay, and then she will have to pay for this course. This is a fixed cost that costs $10. So she wants to spend no more than $280 for both of these. And the boat rental is available only for a whole number of hours. So we need the maximum number of hours that she can rent the boat for. So the equations are written here, but we can do it out. So it's easier to see like the logic behind this. Okay, so this boat rental costs $60 per hour. So we know that since this is per hour, we kind of need a variable for that. Okay, so now we have 60 times x. Let's just make x the number of hours we rent the boat for. She will also have to pay for this water safety course. And this is a fixed cost, so we have to add this $10. Okay, and this has to be less than or equal to, because she wants to spend no more. So no more than $280. So it has to be less than or equal to $280. So we have that 60x is less than or equal to 270. And if we do this out, it's x is less than or equal to 4.5. Okay, but we see that this boat rental is available only for a whole number of hours. So the only value x can be, well, the maximum it can be for a whole number of hours is 4. Okay, so we can move on to our next section, which is Passport to Advanced Math. This is a very packed section, so we are probably not going to finish this today, but we can continue the slides tomorrow. I will still post them in the Google Drive though. Okay, so we will have quadratics first. So let's figure out what exactly we need to know for these. Okay, so for quadratics, we have these many forms that we kind of need to memorize. Okay, so there are 3 forms. The first one is standard form. This is what they're always going to give, or mostly what they're going to give on the test. So they have that f of x is equal to ax squared plus bx plus c. Okay, and a is not 0. So this is a quadratic because the degree, or like the power that x is 2. Okay, so that defines a quadratic. If a is greater than 0, then this parabola, which is this graph, is pointing upwards, and the minimum value is at the vertex. Okay, if a is less than 0, it is a downward parabola, and this is the maximum value. This axis of symmetry in this equation would then be negative b over 2a, and the vertex which lies on this axis of symmetry would be at negative b over 2a, comma f of negative b over 2a. So that is for the standard form. For vertex form, we get the vertex much easier. It's much easier to find the vertex. Okay, so we have that a times x minus h squared plus k, where a is not 0, would be the vertex form of this. This is basically just completing the square from the standard form. So we can get this h and the k, and we can convert from the standard form to the vertex form, or we can expand out the vertex form to get the standard form. And so for this one, the vertex would be at h, k, and then the axis of symmetry would lie on x equals h, and then the vertex, okay. And then we have the factored form. So the factored form gives us the roots. The roots would be where it intersects the x-axis. So we have a times x minus x1 times x minus x2 is f of x. So we have that this axis of symmetry would be the average of these two roots because it's symmetrical about the two sides, about the vertex line, that axis of symmetry. Okay, so x1 plus x2 over 2 would be where this axis of symmetry would lie, and then for the vertex, it would be x1 plus x2 over 2, comma, f of x1 plus x2 over 2. Okay, and then for solving these quadratic equations, we have some methods. So we have the factorization method. So if we have this standard form, we can factor it into x plus 5 times x minus 2 equals 0. So how I factor this, because if we have this a times x minus r1 times x minus r2, this is like the form for the roots. So if we have this and we expand it out, we have that this 3x would basically be the same as negative a times r1 plus r2, and then this negative 10 would be the same as r1 times r2. So I kind of just try to guess and check. So we find what negative 10 is equal to. So we have to have a product of two roots, has to be negative 10. And then we have to have the sum of those two roots to be equal to negative b over a. Well, the sum of those two roots has to be 3. Okay, so we have that for this one, we can kind of just know from looking that negative 10 equals 5 times negative 2. So I write them, I'll write it smaller, so 5 and negative 2. I'll write them in a line like that. Okay. And then we have that this one would be just 1 and 1 because this left side has to also be factored into two things. So this is just 1 times 1. And then we have this kind of cross sum. Okay, so we have 1 times negative 2. This is just basically the distributive property. So we have that 1 times this negative 2 plus the 1 times the 5 should be equal to the 3. And that is like the sum part of my thing. And so that is usually how I factor, and it's really easy to find these roots like that. This actually comes from Vieta's formulas, which I was kind of referring to earlier, but Vieta's formulas just give us that this r1 plus r2 is equal to negative b over a, because if we plug in that this is negative b over a, it gets us the b that we want here. And then we have that c over a is r1 times r2, which is this part. We also have our quadratic formula. Okay, so this you probably have to memorize. X equals negative b plus or minus square root of b squared minus 4ac over 2a. And one important part of this is b square root of b squared minus 4ac, or just b squared minus 4ac. So this is called the discriminant. Okay, so if this discriminant is greater than 0, then that means that there are two distinct real solutions. It can be rational or irrational, but they're real solutions, okay? The next one is when the discriminant is 0. this is when there is only one distinct real solution. Both of the factors are the same. So basically we would have x minus r1 squared. Okay. So the last one is when there are no real solutions. It's when the discriminant is less than 0. This is because you can't take a square root of a negative number. So b squared minus 4ac has to be greater than or equal to 0 to have a real solution. Okay, so now we have domain and range. Note that we need to use brackets for included and parentheses for excluded. So if you have like, I'll give you an example. So if we have bracket 2 comma infinity, infinity always has a parentheses over it because it is always being excluded. You can never reach it. Okay, and then like we can have 2 and 3. So 2 and 3 are included in this. Okay, so domain, it's the set of all inputs that are defined for the function. And then the range is like the set of defined outputs for the function. And for a function, for every input, there can only be one output. Okay, so this, if you draw a vertical line like this, there can only be one part of the graph it hits. Okay, so now let's look at determining the equation of a curve from a graph. Okay, so we have 2 examples. You can try it. Okay, I will go over the first example first. I did not see anyone who gave me an answer, but for this one, we looked at our graphs before. We know kind of how they work, and so we can see that we can use Vieta's formulas for this. Okay, so we see 2 roots. Their 2 roots are the intersections at the x-axis. That was a very bad point. Okay. So these are the 2 roots, and we also have the axis of symmetry. And this is the average of the 2 roots. And we also know that this graph is pointing down. Okay, so we have that since this graph is pointing down, A is less than 0. We already figured that out. That works. Okay. So we have that B is greater than 0. This is what we're trying to test out. Okay, so if we have Vieta's formulas, we have that negative B over A is equal to R1 plus R2. So R1 plus R2 would have to be positive because this axis of symmetry is positive, and that is the average of the 2 points. So if we multiply this average by 2, that would be the R1 plus R2, and that would also be positive. So if we have B equals negative R1 plus R2 over A, because negative B over A is R1 plus R2. Okay, and then so from this we have that since we have R1 plus R2 is greater than 0 and A is less than 0, so A is also a negative number. So if a negative number is divided by a negative number, we have a positive number. So B is greater than 0. That is true. Okay, for the last one, we have C is greater than 0. Well, C over A is supposed to be R1 times R2. Okay, so since C is R1, well, C over A is R1 times R2, and A is negative. This is negative. Here, I'll just say this is less than 0. This is negative because one root is negative, one root is positive. So negative times positive is negative. We also have that A is less than 0. So then we have C equals the product of these two negative numbers. So C has to be positive. And so all three of these are true. And so we have D. Okay, I will give you 2 more minutes for the next one. Okay. I don't see anyone who has given me their answer, but I will also go over this one. Okay, so the trick to this one is to draw the graph. So we know that A is less than 0 and K is less than 0 because that's what we are given. Then we can get that f of 0 cannot be negative K. So if we draw this graph, we have that this parabola is going downwards because A is less than 0. So it can be anywhere like that. But we are also given that K is less than 0. And remember, since this is in vertex form, we have that the vertex would be at h comma k. So this parabola can be like anywhere like this, but at h comma k, that's where the vertex is going to be. But k, which is the y value, is negative. So it's somewhere below that x-axis. Okay, so f of 0 is always going down from h comma k. So it can never touch that x-axis. It can never be positive because negative k, since k is negative, would make negative k positive. So it can never touch a positive side of the graph. Okay, so now we can look at the discriminant. Okay, so from our quadratic formula, we have that the discriminant is b squared minus 4ac. If b is greater than 0 and b squared minus 4ac is a perfect square, we know that the roots are real, rational, and not equal. So there are two distinct roots. And then for the other one, if b squared minus 4ac is not a perfect square, then we have that these roots are irrational, okay? And then if d is 0, we already know that this is real, rational, and the roots are equal. So it's going to touch the x-axis at exactly 1 point. It's tangent. And if d is less than 0, it's imaginary. That means that the graph does not touch the x-axis at all. Okay, so this is an example. It might be a little bit harder, but in this graph, we have that f and g are tangent to each other. It touches at exactly 1 point. So what is the value of k here? I'll give you 2 minutes. Okay, so now we can start to go over the answer. Okay, so we have that this is tangent, so somehow we need to find a discriminant. Okay, that is like the main idea of this problem. Okay, we have that this graph is x squared minus 4x plus 8. Oh, I forgot to show the answer. The answer was D. Okay. I will move on to the next slide because that may be easier. Okay, so we have that x squared minus 4x plus 8 is the graph of the first one. Okay, and we're trying to find the point where these two equations are equal to each other. Okay, so the point fits both of the equations. That means that we can put an equal sign to make one equation equal to the other. And then we try to solve both of the equations to be equal to each other and find the x value where it works. We know that these two graphs are tangent to each other. So we know that x squared minus 5x plus 8 minus k equals 0. And the discriminant of this must be 0 because that's when there's only one root. They are tangent. Okay, so that means that, remember our quadratic formula, we have b squared minus 4ac. Since a is 1, I'm just writing 4 times a minus k. This must be 0. So we have 25 minus 32 plus 4k is 0. And so we have 4k, I'm skipping a step again, is 7. And so k is 7/4. Okay, and that is how we got D. This probably will be the last section we can cover. So we are trying to solve these equations by factoring or rewriting them in another form. So, polynomial factoring graphs. So we have a couple of theorems here. The first one is the factor theorem. So if we know that x equals c is a root or solution of this equation, f of x equals 0, we know that x minus c is a factor of f of x. This is pretty intuitive. And then the graph of y equals f of x intersects the x-axis at c comma 0. So we know that it touches that line at c comma 0. So it can be like that, or if it's like a cubic, it can be like that. And then we also have the rational root theorem. So this is if a polynomial with integer coefficients has rational roots, the numerator of the root of of any of these roots must be a factor of the constant term, and the denominator must be a factor of the first term's coefficient. So in this case, it would be a 1. And these can be negative too. Okay, so we can try the first example. This relates to the factor theorem. So I'll give you a minute because this is pretty fast. Yeah, so the answer would be B, because it has the root of x minus -1. No, it has a root of -1, so we have x minus -1 would be a solution. Well, I think I accidentally wrote it wrong on the slide. I somehow wrote A. I fixed it. Okay, so that should be B. Okay, so the next one is an example of the rational root theorem. Okay, so this one should also be pretty fast. Just test the different solutions you can have. Okay, we can go over this one now. So for the rational root theorem, we know that the numerator of the root would need to be a factor of 8, and the denominator would have to be a factor of 1. So I always try 1 and -1 first, just in case, because those are the easiest to plug in. So if we have 1, then we plug it in. We use this factor theorem to plug it in. So we have 1 cubed plus 3 minus 14 plus 8. But this is not 0. Okay, so now we try the next one, which is -1. -1 plus 3 plus 14 plus 8. This is not 0 either. So then we go on to x equals 2, because 2 is a factor of 8. So we have 8 plus 12 minus 14 plus 8. And this is actually the answer, because this gets us to 0. Okay. So, next one. Oh, I think I wrote the other one. Wait. I accidentally read the other one wrong. But, oh. Okay. This one, you just plug it in. It's supposed to be minus 28 plus 8. Okay. So now we have our polynomial factoring in graphs. We can go over these examples really quick, and I will introduce to you the concept of multiplicity, and then you can hold that thought for the next time. Okay, so this is basically the concept of multiplicity. Okay, so if we have these equations, if it bounces off the x-axis, like a quadratic equation, you can imagine that this is like a polynomial, a quadratic right here. This means that there are 2 roots at x equals 0 here. So it has to be a square. If it passes through just like a line, like at here and here, this would just have one, like a factor of, like 1 factor of this would be a root of this polynomial. So this answer would be at x plus 3 times x minus 0 squared, so this is x squared, times x minus 2. So this would be B. And then for this third example, we have, we basically just use the concept, well, the factor theorem basically. And we see that if we plug in x equals 3, x equals negative 3, we look at these answer choices, they both work. And we see that x equals negative 3 is one of the roots over here, because x plus 3 is x minus negative 3. And that is what we get from the factor theorem. So that is our third example. I will talk more about multiplicity the next time, but I will skip to the end slides so you know what to do for the next workshop day. Okay, so for the next workshop day, you can try a few practice tests. So you can kind of gauge like which topics you have trouble on, and you can come to the workshop next time with questions, and I will also be having like frequently missed questions. I will go over those with you at the beginning of next class. And then practice test 1, the link is right there. And then the slides will also be posted on the Google Drive. And you can also check your raw score based on previous year scores. Just click on this link. This will just get you back to this scoring slide. So it's pretty easy to work with. And yes, you are getting the recording. Okay. So thank you for coming today, and sorry for going a little bit late, but I'll see you next time. Bye.